So I've gone ahead and I've created an AND gate. And this is the AND gate here. So it's the same as we've got for the NAND, the NOR, and I've renamed the inverter NOT. Okay, so if you just right click there, and you can see there's a rename cells and group. So I've just renamed them all NOT as opposed to inverter, because we just want to refer them to the actual Boolean logic. So in order to create the AND gate, in order to create it, we can create an AND gate using the NAND and then put the inverter after it. So when I went in to create this schematic here, I can create the schematic just by picking out the NAND schematic here. So this is the NAND here. So I can just pick out this, which is the actual icon, and I can just place the icon. If you wanted, you could place a schematic. It's up to yourself, schematic or icon. So I placed the icon here, okay, and then I placed the NOT icon. I just joined them together, and I ran through the usual process of checking this out as in a simulation that you've done with the previous examples. So we've got our NAND follow with a NOT, which is going to produce our AND gate, which you can see here. Okay, I'll zoom out a little bit. Okay. Now, I've also created the AND in the layout. Okay, so that's the layout here. And again, I've got the NAND layout and I've got the NOT layout. So I've just gone in here and chosen the layout for the NAND here. Okay, so that's just this one here. And I've got one for the NOT as well. And then at this level here, I've joined them together. So the VDDs get connected together, the ground gets connected together, and the output from the NAND goes to the input of the NOT. There's only one little difference. I shifted this output here. Previously it was sitting down in here, and I just shifted it up here. Okay, it was for easier access. So from this we can then run through our simulation. So if you look at the simulation file I've created, simulation file for the layout, and go into the tools, Spice, right Spice deck, and it creates the simulation. So from the simulation we can click on the waveforms, VA, VB and Vout, add plot plane, add plot pane, and we'll grab the VA, VB there, and the VA is up the top. So these are our inputs. So VA is high, VB is high, the output is high. But if either of them are low or both low, then we've got a low output. So this is just our AND gate, and you can see that's working. And we can see that it's extracted all the parasitics in this example here as well, C0, C1, C2, and all the resistances as well here. Now, one other thing that we can look at here before we go is the 3D view. So we'll head into the AND layout, and this is our AND gate, and we can get into the tools, window, 3D view, and this is our 3D view here. And you can see the 3D view here. So we've got our two inputs here for our A and B, and we've got our output here, which feeds into the input of our NAND gate, or sorry, our NOT gate, and that's it feeding down through here. That's the input to the actual gate itself. You can see down the bottom. And we've got our output here, which is our final output. So it's our two inputs for our AND and our output for our AND, made out of a NAND gate at the top and an inverter at the bottom. So that's all for this video. we'll continue on and we'll build up the OR gate from the NOR and the NOT, and we'll also build up an exclusive OR. So thank you for listening. I'll get you on the next video. Goodbye.